Okay, for those of you who are just joining, welcome. Today, what are we doing today? Intersect method of hazard analysis
Intersect.
with Jim Vaughn. I'm Jamie, work for ISPC and T&D Power Skills both. As you know, ISPC is a nonprofit, so I put a link in the little chat box. If anyone chooses to donate, it is tax deductible. I send you a little letter, yada, yada. So click the link if anyone wants to donate. Also, after the webinar, if you would like to earn CUSP points, for those of you who are CUSP holders, just shoot me an email, jamie@ispconline.com. I will send you something verifying that you attended today, and then you can use that to apply for your points whenever you do that throughout the year. So with that, I'm going to hand it over to Jim. There's a chat box and a question and answer box at the bottom. If anyone has questions during, I will interrupt Jim and ask them for you and get them answered. But as he said earlier, he's designed these pretty well, so most questions will probably be answered before they're asked. But should something else come up, just type it in and I will interrupt him and get it asked. With that, I'll hand it over to you.
Okay, thank you, Jamie, and thank you everybody for joining in. Now, of course, we can't give away this great information you're going to get in a minute without a commercial. So I do want to tell you about ISPC. You're probably already familiar with us and ISPC, but you may not be familiar with T&D Power Skills if you're not using any of the materials. T&D Power Skills is essentially an apprentice program. There's 78 lessons that are in it. They fit perfectly and are used by many, many companies, and I'm saying by the hundreds of companies that are using this T&D Power Skills materials for their registered apprenticeship programs. But the material is extremely flexible. It's designed around videos that we are constantly updating. I'm one of the writers of the materials for the training program. It also has student workbooks that go along with that. The package comes with available T to T, train the trainer. We send experts out along with the material to teach your trainers how to use the materials to their best advantage. But there's so much flexibility in it because you can also use the LMS system, which is a computer based on our network, where they dial in and they can see the lessons right there on the LMS system. And the LMS system also keeps track of how many hours your students, your trainees, your apprentices spend on the program and what they've been studying and what they're working on. And it's an all-around perfect program for almost any application because we got wizards there in the computer business that know how to put these packages together, and we can even do it so we can put your information or your training materials into the system also, and we can customize programs just like we do at ISPC. We customize for our clients. So we're talking today about the Intersect. I want to tell you where this came from. We investigate incidents as third-party investigators, and the reason why utilities do that or contractors do that is that one thing is they may not be or have the expertise to do a detailed investigation, especially if it's a serious incident, that occurs, and then they also sometimes want to divest themselves of any claims that they are have an agenda with their investigation. And then a lot of times it's because we do investigations because of OSHA actions or activities or civil liabilities. And I'm the senior member of the staff that I handle these litigations. So we've done hundreds of investigations, and I started trying to count back one time, looking at the number of them that I do a year and the 49 years that I've been doing this and the 25 years I've been doing safety. And I figured that I'm probably doing some 700 investigations. Well, that's where this idea was born, because one of the things that is common to almost every investigation that we do or every accident we investigate is that the tailboard or the preparation was incomplete. Now, we can't always say that that actually had something to do with it, but we put it this way. The mechanism of injury that caused the event or caused that's the act that caused the event or caused the injury was not discussed in the tailboard or was not written in the tailboard or was not checked off in the tailboard. I'll give you a for instance. we had a metal clad switchgear contact that occurred. And when I went to investigate, I talked. Nobody was killed. Guy got some burns on his hands and some burns on his face. This was before the FR and face shield days. And what they were doing was they were replacing the feeders that were leaving 4 kV switchgear that were going out into a big mine processing facility. And so the plant was shut down. The motor control center for the 4 kV gear was still energized on the bus, but they locked out and opened every one of the breakers. And if you're not familiar with metal clads, the breakers slide out and can give you access to the cable terminations on the inside. So everything was switched out. For 2 weeks, they had been working on replacing these things. There was about 22 lined up breakers that were here, and every day it said check for voltage. And what they were doing was sticking a tick tracer inside of the switchgear cubicle, and they were sweeping it across the back of the cubicle where the conductors were, and they were checking for voltage. Well, what they didn't know was that in the previous 10 years, when the plant started going to auto control systems and supervisory control systems, they decided to put a power supply in the loads on the line side of the switch that would keep the controls powered up so that they could have a power available to open and close these breakers remotely. But nobody ever changed that. These guys were contractors. They didn't know that. When they swept the back, they never came across that little 4 kV to 120 volt transformer. It was 4 kV, but it was phased to ground. That was mounted up in the top left-hand corner. Well, one of the things that they do when you terminate an underground cable is that you put the concentrics all together, and then you bond them to the ring bus on the inside of the cubicle. And when they were flipping that piece of copper around, they got it into the top of that a little transformer, and there was quite into 4 kV creates a pretty big blast of heat and air, and it blew up and knocked him back. Fortunately, he was on his knees and wearing a pair of boots, so his path to ground was very low, which limited the current. He did get blood tests that indicated that he had been electrically shocked, so we know that was the case, and he had some flash burns on him, but they said they had no idea what could have possibly happened. But we went back, and typically when I do an investigation, I go back to 2 weeks of the crew's tailboards to get a feel for how they were conducting their tailboards. You know, I can look at one and I can hear explanations, but if I look at 2 weeks, I start to find some commonalities that indicate that maybe things weren't the way that weren't as good as they could be, like the routine stuff that you see all the time: stay out of the bite, wear your PPE, be careful walking, you know, the kind of things that you see on or written on tailboards all the time. Well, after many years of seeing things like this where major hazards were not discussed, we started working on, we said, we've got to find a method to make this work. And I started drilling back down to my days as an apprentice and as a lineman. And I remembered in particular one thing was that when I became a foreman at Florida Power and Light, it was my first day with my crew standing at the foot of a pole that we were getting ready to change out that I realized that I didn't know how to do a hazard analysis. Now, we didn't call them that. You know, at the time that hadn't come around. You remember I was a lineman in a previous century, and OSHA had not gotten really into the power utility business the way that they are now. And we had tailboards, but it was about the work. And 4 or 5 of us would stand there. We'd listen to the foreman, and he'd tell us what we're going to do, and we'd all nod our heads, and then we'd go out and we'd do our work. But we were never challenged with having to think it through ourselves. And so suddenly, when I had to do it, I didn't know how to do it. And I finally caught myself by surprise, and I just told the guys, and these guys were linemen that I'd worked with for years, and I just said, "Hey, I've never done this before." And so we started talking about the work. But I remembered that I didn't know how to go about doing the a hazard analysis. So we're going to get to the Intersect, the actual process toward the end of this. And of course, this is a very short presentation. The whole thing, we're going to do this inside of the hour, and it only takes about 10 minutes to tell you how the Intersect works. But what we need to know is to understand, especially if you're going to adopt this process or consider this process, it's best to know why we do what we do so that we can better understand how the Intersect solves that problem for us. So, OSHA has given us some guidelines. They've told us what it is that we have to accomplish. And that's the thing about OSHA is OSHA's rules are what is known as performance language. In other words, that name is a little misleading because it's not how you perform something, it's what you're supposed to accomplish when you do it. So that's what performance language is. It is not procedural language, which how you accomplish something. Uh, Now, OSHA's language in a number of the rules that came out in 2014 in the last revision of the OSHA standards for our industry had a lot more procedural language in it than they have ever had. And they even acknowledged that in a couple of non-statutory publications that they did. But they felt like it was necessary because they couldn't figure out how to say it best. But for the most part, the OSHA statutes are this performance language. And that's part of the problem with our safety manuals is that when people write safety manuals and don't understand or maybe not safety professionals or have a lot of experience in it, they tend to copy the text out of the OSHA standard and put it in your book. And now you have a rule that says that this is what you're supposed to accomplish, but not how you do it. And that's where the tailboard starts to become valuable also, because in the tailboard, we're supposed to be talking about how we're going to do something. But OSHA created for us some expectations of the tailboard, and there was a lot of new information, and everybody on the call probably remembers all the changes that we had to make to our tailboard process, and you remember the rules that came out. So here's three boxes here. Determine the tasks necessary to complete the job and hazards associated. So really that could be the number one role, is to determine the tasks. And then in our investigation of incidents, the task identification is the one that's missed most, that has the greatest effect. We constantly find that these tasks, and this is what I told you earlier, the mechanism of injury was not discussed in the incident. And I also have to tell you this: one of the first things that OSHA asks for and we know this because remember, I'm telling you now from my experience in the defense of employers in court actions between OSHA and employers. I serve as an expert witness on how the employer operated, what the rules are, and defending the employer. We consistently see OSHA using the tailboards forms as a tool against the employer. Got it? A tool against the employer. Now, here's the thing about the tailboard and the tailboard form. OSHA demands that your crew do a tailboard. They say that the supervisor shall conduct a tailboard or hold the tailboard. Now, the supervisor can use whatever tools at his disposal. OSHA doesn't tell him how to do that, and he can use people on the crew to do the tailboards or to contribute to the tailboard or to the process. Probably uses a form. You probably have a form. Well, when OSHA shows up in an investigation, the first thing that they ask for is your OSHA 300 logs. They ask you for your safety manual or your safety program, and then they ask you for your crew's tailboard reports. If you don't have any tailboard reports, you'll never hear anything else about it because the law, OSHA, does not require that you keep tailboards reports or forms. Now, they say that it's a good way. And of course, if you're going to try to prove that you're actually conducting tailboards, most people think, well, we'll do a form and we'll fill it out. But the problem is that our job hazard analysis is reflected in the tailboard. Now, how many of you have ever been able to write down exactly what you discuss? You can't do that. You make notes, and if somebody hands you a pre-form one where you just check a box or circle a word in there, then that's left entirely open to the interpretation of the reader as to what you did and what you talked about. Now, I'm a lineman. If I see somebody circle a box and I know what the job was, I can pretty much guess what that discussion was. OSHA is not. And when they look at tailboards, I actually had the former head of the department in OSHA that wrote the standards testify that the quality of the tailboard was a direct result of the accident that killed the lineman. And he said that never having done a lick of work in the line industry. And they used that in their prosecution of the employer. Now, we eventually were successful in arguing his expertise. How could he possibly know? And it turned out that he even had to testify that he had only ever seen one tailboard be conducted in his 25 years at OSHA, where I, on the other hand, had probably done somewhere between 12 and 17,000 of them in my 49 years. So my testimony tend to have a little more weight than his did. But you need to understand and get the point is that the quality of your tailboard, the quality of your hazard analysis, if you are recording them, that's great. It can defend you and say, we know for sure that our crews are doing tailboards because we have them fill out this form. But at the same time, if they're not doing it equally well, if they're missing blocks or if they're doing a lot of repetitive material, then they can be used against you just as well. So this is a reason why training to do tailboards and the reason why we developed the Intersect process to create a very simple way of doing an effective tailboard so that you can actually explain this. And I have defended employers that have been using the Intersect for a few years, and I bring this up in depositions. I describe the process. And when we do that, it's never an issue after that. OSHA completely drops the idea. So if you want more information about that, I've written on it in Incident Prevention Magazine. We teach it in our training, and we'd be glad to share information with you if you or your lawyers have some questions. Now, a lot of companies have a hard time doing this until their legal counsel or their legal guidance comes up and when they understand the rules and how it works. The very best thing you can do, though, is to have a good tailboard that reflects a good hazard analysis. The number two element that we find that makes mistakes on your tailboard is the failure to stop work when something new or unexperienced. This is a cardinal rule, and everybody knows this. You do a tailboard plan, which is a work plan, and you probably have heard the adage, plan your work and work your plan. But linemen don't do it that way. We have spent and been trained to do if thens. In other words, if we see this, we do this. If we see this, we do this. We are problem solvers to the top degree in a very hazardous environment. And so when we get to something that we didn't plan, we simply solve the problem and move ahead. Well, the issue with that is that that doesn't meet the OSHA standard or the OSHA expectations. The expectation is, and by the way, if you take a close look at how OSHA, and you remember, we have horizontal standards or safety rules that apply to every industry, and then we have vertical standards that are safety rules that only apply to very specific industries that have very specific, unusual workplaces. We are a vertical industry, and what OSHA recognizes is that the quality of our training and our awareness of the hazards in the environment is what keeps us safe. That's the reason why we can move up to within just 18 inches of an energized conductor where everybody else has to stay 10 feet back. I was just arguing a case where a lineman fell off of a roof, arguing a case that OSHA recognizes that 15 minutes on the roof awareness and training has a very high success rate. Our falls off of roof indicate are extremely low compared to other industries that work on rooftops because of the amount of time that we spend there. So it was hard for them to understand. You will understand it better. It's our training and awareness that makes it work. Now, the problem is that OSHA then, they've dictated for us, and we're the only industry that they have done this for. They dictate for us how we keep our workplace safe by identifying the work task and the hazards associated. And then if we come up to a hazard that we did not anticipate, we are supposed to stop work. Everybody gathers up, we discuss what we found, and we decide how to do that. In other words, we have an appendix to the tailboard. And if it's a big enough issue, then we do the whole tailboard over again. But we don't do that. And that's exactly what happened right here. This guy on the ground has many years in experience. He was an apprentice when I first met him, and I did a lot of training with him. And then he went up and did something that he absolutely knew he wasn't supposed to do. And he ended up with an induction contact that knocked him unconscious. And you see there paramedics tended to him after he came back. He had some burns, on his body, went to the hospital. He survived it. He was fine. But the thing was that when they found the problem, they never discussed it with anybody else. They went about to adjust their work procedures, and they didn't call down and stop and boom down and go back to work after they had discussed the issue. If they had, their foreman or the leadership on their crew would have said, no, don't do that. But that didn't happen. So that's another one of our big mistakes. Now, how many tailboards are necessary? Uh, what I find, especially on construction sites, is that we'll get the whole construction gang together. And I mean, when we were in Puerto Rico, there was 200 people in a tailboard. and the managing contractor would do these daily morning safety huddles and talk about safety and some safety topic over a megaphone, and everybody was standing there and listening, and nobody was paying attention. It was still dark, and everybody's eating burritos or drinking coffee and smoking cigarettes, and little side conversations are going on, and then everybody went out and did their work. Now, I hope, and certainly the crews that we worked with would go out and they would have a tailboard at each one of their work sites. And that's the kind of thing also that should be happening in our larger construction sites. We may have a tailboard or a crew meeting or a huddle in the morning, but when we get out of the job sites, we need to have another tailboard. But here is one that I have seen a number of times that does not get attention. So this is just another example. So this crew's going out to the job site, and they need to position this tugger, and they go out there and get stuck. And the first thing that happens is that everybody starts running around, starting saying, grab a rope, get the digger derrick over here, put a rope on here, put a line on here, and they're blasting their way trying to get this thing unstuck. And then they end up pulling the bumper off the front of the truck, or pulling the frames skewed sideways, or something, or breaking. We've even had people break lines and knock the windshield out of a digger derrick truck. That kind of stuff. These are the kind of things that crews have to recognize deserve a discussion where everybody stops and takes the time to make sure that things are going to be done right. So it doesn't have to be real complicated. It just depends on what the type of work is. And that's also the same thing about the form. The form itself, I've seen forms that are 5 pages long. Now, anybody on this call, if I ask them, what would you think about a 5-page long tailboard form? And I think most people would say, well, it must be complete. It must include everything. But do you think that a crew is really going to do a detailed study of a 5-page form? It doesn't have to be that complicated. But of course, it also depends on the skill and knowledge of the crew and what they're going to do. So what we call that, like a 5-page form, or if it's very complicated or detailed, then what happens is that the form itself becomes a task. and the tailboard then becomes a task. And what I see in a number of audits, uh, hopefully when we do an audit, what we always try to do is meet that crew on a job site in the morning so we can see their whole process. I even like to be there before the crew shows up so I can see them place their equipment and see what everybody does. And usually what happens is that everybody knows what's going to happen. And so some people start doing work before the foreman ever even shows up and nobody has a tailboard. They're out there laying out equipment and putting out outrigger pads and putting outriggers down and swinging the boom around and doing all that kind of stuff before anybody did that tailboard. So there's a problem. So when crews start doing tailboards where it becomes a task, what we see is that the crew meets, they do the tailboard, they pass the form around, everybody signs their name on it, which is another thing that you don't have to do. There's no validity at all in court to the signatures on a tailboard. It simply means that, they say, well, his signature wasn't on there. And you say, yeah, but testimony is he was there. And they go, oh, okay. Signature is only important if it's actually notarized, right? Legal. No, it's not. Doesn't mean anything, but we still sign them. We should be printing the names down so we know exactly who's there. But because of the dozens of tailboard forms that I've examined in court cases, nobody can determine who signed that form. They say, well, I think that name is such and such. And I've seen an hour and a half of discussion in a court complex case over one signature because nobody could read what it was on there. And it doesn't even make any difference because it's actually the quality of that discussion and then of course the record. But the problem is when it becomes a task, because what happens is the crew stands there, they pass around the form, they do their little safety minute or whatever it is that they're supposed to do, and then after they've done the tailboard, then they start discussing the job. Who's going to do what, where you're going to do this, how we're going to approach it, go in from the side. Let's take the transformer off the pole first. Should we ground the trucks or what do we ground to? But they're not talking about safety. Now they're talking about doing the job. So what happens is that the tailboard becomes separate from the actual discussion of the work. So the challenge is to put them together, and that's another accomplishment that you'll find with the Intersect. So task or tool. I want you to take a look at this. This is off of a tailboard form that I got from one of my clients. So you see here, parking hazard, electrical hazard, fall hazard, lifting hazard, ergonomic hazard, environmental concerns, mechanical hazard, likely injuries, and then you have all the list of stuff that you're supposed to do: safety glasses, hard hat, dust mask. Now, what do you see on this left-hand box? What is the nature of the questions? Well, what you should notice is that it's asking about hazards. So they're approaching the hazard analysis from the aspect of the hazard and then trying to figure out if it exists, but they don't talk about the particular work or the procedures that they're going to use to handle it. So you see down in the bottom box, the statement is that this mechanism or this form creates focus on the hazard as opposed to the focus on the work or the steps to perform the task. So this becomes more of a task filling in the box than a work step analysis tool. So what we're doing then is we're looking down this and we're going parking hazard. Yeah, I guess there is. We're working in a parking lot. So yeah, that's one. Electrical. Yeah, the feeder's hot. Yeah, so that is. Fall hazard. Yeah, we got to wear harnesses when we're working out of the bucket. Lifting or lowering hazard. Yeah, we got to pick up those two of those 80-pound cross arms. Ergonomic. Oh yeah, man, rubber gloves really mess my hands up. Environmental concerns. Yeah, there's a beehive up there in the top, and I think it's going to rain today too. Mechanical hazard. Yeah, we're booming up and moving around and putting outriggers down. Yeah, that is. Likely injury. Heck yeah, you can get hurt doing this job. That doesn't tell you anything about how we're going to accomplish the work. So when we build a hazard analysis from a checklist of actions, we call that a random approach, because if you think back, that's actually how, if you've ever done that checkbox, That's just about how you think your way through it. You might have thought that I was joking when I was reading those things, but that's actually what happens. That's what we do because we know we got to fill out that form, because if I don't fill this form out, somebody's going to come by and get me. And that's when it becomes a task in itself, not a tool to analyzing the work and keeping employees safe. So we do want to focus on hazards, but not from the aspect of the hazard list, because when we do that, we start missing stuff because we're not discussing how the work is done. However, if we do the hazard analysis from an ordered work step, in other words, everybody knows how it is that we're going to perform a job. If we're changing out a transformer or going to hang a transformer on a pole, there's hardly anybody in this group that doesn't understand what that requirement is going to be in order to get that transformer on the pole. And you could probably walk through each of the steps that are going to happen. Now, we need to start those steps from the time we pull up on a job site. But from the time we park our trucks to the time we close the switch on that new transformer, almost everybody here could go through each of the steps. And that's what's been missing in our hazard analysis. When we combine the plan with a hazard analysis, now we have an effective way of identifying those hazards because we know each of the steps. We know what we're going to do. So what we do then is we identify the hazards relating to the steps as we do them. When we do that task step, then we have a detailed discussion. And usually what happens is that, and I can say this, with a lot of confidence, we now have a much better plan on how we're going to do the work, because instead of looking how hazards are available on the job, we now look at how the hazard is associated with each of the work steps. So that's how the Intersect works in that way. What we're trying to do is identify every condition, situation, practice, or behavior that can cause an injury, and we can't do that if we haven't done a successful of analysis. And I can tell you also, I mentioned earlier about this thing about arriving with trucks on the job site. We did a hurry up, absolute, had to get built substation. We had 4 months to get this thing in the ground on a green field. And we were going to put a whole bunch of people in the substation at one time. It's kind of unusual to have 25, 30 people working inside of a 1 acre substation, at the same time. And we managed to do that without one injury or incident. And we had a very tightly controlled work environment. In fact, we used the Intersect in this process while we were building. The only injury that we had was on the second day of material mobilization. They were still grading the site. A site contractor grader was still cutting this greenfield space down, still grading when the first tractor trailer arrived with a helper and a truck driver, and they were unloading bolts and pieces and stuff like that. They were unloading some steel sections, and a forklift was moving in underneath the steel section. The apprentice who had been unstrapping was up on the truck, and he really wanted to be helping. He was really enthusiastic, and he was guiding in the forks to the edge of the steel, and then he went to get out of the way in a big hurry, and he tripped over the steel behind him, and he went off of the truck, and he landed on his shoulder and broke his collarbone. That was the only injury on the whole 4 month site, working 10 hours a day, 7 days a week with 35 personnel on the site. And they didn't do a hazard analysis. The truck driver operating the all-terrain forklift did not talk to the apprentice about what his role is and how they were going to pick this stuff up, or what the hazards were, or what they were going to do. They did not do it. We don't do it in the yard. We pull into a yard to pick up material. We don't do a hazard analysis before. Maybe you do, but most people don't do one when they're picking up material, because that's not line work. That's picking up material. But it makes a difference. And sometimes it's really easy. It's going to be a tub of material in a material box they just throw on the back of a truck, and that's no big deal. Two guys pick it up, they throw it on the truck, they tie it down, you're gone. But other times you're setting poles on the back of the truck, or you're moving steel, you're moving heavy transformers, or three-phase transformers, or 15,000-pound spools of wire. Those things have hazards associated with them, but we rarely get around to doing that hazard analysis. So when we do hazard identification, we're actually using that left brain fish on the beach phenomenon. If I told you that the tide had gone out very, very quickly and trapped a whole bunch of very big snook on the beach, or fish on the beach, you would know exactly what I'm talking about. That's that left brain capacity that we have, that we can remember stuff. But we also learn about the kind of incidents that occur from things that all of our companies use to train us on how to prevent accidents. But I think the biggest one is the been there, done that. Those people that are standing in that group. If I have 5 people in a group that's doing a tailboard analysis, and I've got one guy that's got 20 years of experience telling you stories from his experience, those 5 other guys, if they've got 10 or 8 or 12 years, there may be 50 years of experience among those other people. So if this becomes a conversation where we're starting to talk about our experiences, now we know how to do better analysis on the job. I'm going to tell you one that I've seen probably a half a dozen times, and it was back from the manual ground rod driver days, the pipe with the weight that's on the end of it. We hardly ever use these anymore, but what I consistently found was that some over aggressive, really excited helper was going to show how fast he could get that ground rod in the ground. And you know what happened? The ground rod driver came off the end of the rod, and somehow your hand ends up over the ground rod, between the ground rod and the ground rod driver. I actually had one guy completely penetrate his hand right through his work glove over the ground rod. And we had to take a pair of hydraulic cutters, and we cut the ground rod off and took it to the hospital with him to have it out. But what happened there? Probably the one of the more dangerous tools to use on the crew was being done by the helper, who had no experience. But there were 4 other people on that job who knew what the issue was, but nobody brought it up. The helper with the ground rod stuck through his hand had never, he said, I can't believe that happened. I couldn't imagine that could happen that way. There's even a guard on the end. My hand was above the guard. How did it end up down there? It happens. But people know that. So we have that discussion to make sure. Um, we also weight hazards. Now, this is the part that when we're doing the intersect, people get concerned about, well, do I have to talk about absolutely everything? I'll be there forever. No, it's not. And even OSHA acknowledges that depending on the knowledge and the skills of the people that are there, not everything has to have a detailed discussion. We're not doing an apprenticeship here. We're doing a hazard analysis. So if I was going to use a scale to do this, I called the pig and feather analysis. So if a hazard is obvious and everybody and it's a serious one, that's a pig. We need to make sure that one gets discussed. On the other hood, if it's unlikely to happen, that's a feather. It's not going to get a whole lot of attention. Unusual condition, is an unusual condition a feather? Well, yeah. Now, see, here's where the feather is heavier than the pig. Inexperienced crew, that's a heavy one. Fatigue on the crew, it could be, but what happens when we have fatigue? What happens when we're working long hours? Or what happens when we're working in storms? We tend to make greater, more accurate observations and take our time getting ready to do things and figuring out what's going on. So the other part is risk, whether or not risk makes a big deal. Now, these other methods of analysis, take a look at what you see here. These probably look familiar. This is a scan off of a real live one done by a real live, highly qualified crew. And you see there, look at the nature of the listings there under safety issues: slips, trips, and falls, improper rigging, loss of load, lack of communication. The one thing that's not there is stay out of the bite and wear your PPE. Those are 2 more of those common ones that we see all the time. So now we're going to look at a new method, or a better method, the Intersect and it's subtitled Where Flesh Meets Threat. Where Flesh Meets Threat. So here's how it works. We know that all of our jobs are made up of work tasks, and we're going to go through all of those work tasks. Now, this is that cubicle that I was telling you about. That you can't see that up in this corner up here. This is where that little transformer was that the guy flipped that piece of conductor into that caused the explosion. So the first thing that we're going to do is we're going to break down the job into manageable tasks. Now, the issue here is, and this is where training starts to take place, is that is this the pig or feather? Does one of them deserve more attention than the other? How do we combine them together? I can't tell you how to do that. You learn to do that from experience. But from there, let's say that we're going to do a job on a job site. We have setups of equipment, inspections of equipment, testing of equipment, unloading materials, then test and ground a bus, barricade, cover up, hanging rigging, cutting jumpers, rigging reactor, remove, replace, install jumpers. This is from a reactor job in a substation. And then remove the barriers, covers, grounds, and switching. And yes, taking that stuff down is another part of the process. You'd be surprised how many fatalities I've done where people taking grounds off of high induction got killed by their grounding that they had put up to protect themselves. So it also has that same requirement that we study all the way through the end. But we're going to break these down into steps, and the steps are going to give us the divisions of work that we're going to look at each step and each hazard that's associated with each one of the steps. So once we've done that, then now we have a basis to do an accurate hazard analysis because we're talking about each of the tasks in the process. And you see here, I got a mention up here of unloading a snorkel lift from a trailer. This is one of those things that gets missed, and because it's not seen as part of doing the work. Unpacking and inspecting porcelain insulators. You don't know how many times I've had newbies or helpers getting cut by broken porcelain, especially on a change out job, and they're walking around picking up porcelain, have no idea that that razor sharp porcelain can cut them. But this is what we're doing. This is the three questions that make up the intersect. So you see here we have the first question. What is it about the task that can hurt me, and how do I prevent it? What is it about the task that can hurt me? How do I prevent it? So we call this task, tools, environment. On these, we have tasks first. What is it about the task that can hurt me? How do I prevent it? Unpackaging and inspecting porcelain insulators. What is it about that task that can hurt me? I can get cut by broken porcelain. Look for broken porcelain. Avoid it. Put tape over it. We have a discussion for people that don't get it. I'm crimping terminal spades on 1590 MCM jumpers. What is it about this tool that can hurt me? How can I prevent it? Well, if I'm using a separate pump, if I have a pump leak, that's an issue. If I blow a hose, then hydraulic's going to penetrate my hands. If I get my hands in between the crimper, my fingers are going to get crimped. All of these are questions that we're asking. So for each task, the worker asks, what is it about the task that hurt me? How do I prevent it? When it comes to the tools, remember our ground rod driver? What is it about the tools used that can hurt me, and how do I prevent it? Now, we're not talking about ratchets. We're talking about power tools. We're talking about hydraulic tools. We're talking about things that have very serious issues where threat meets flesh. That's not usually a socket. So we're talking about power tools or making choices. And then what is it about the work environment that can hurt me, and how do I prevent it? The work environment, that also includes things like tornadoes, especially if you have people that are new to your region. If you work in Ohio and you have a guy who just came to you from the Keys, yeah, he knows about hurricanes, and he knows that he's going to know about it 4 or 5 days ahead of time and what to do and where he's going to go and how he's going to protect himself. But he doesn't know about a tornado that shows up and 2 minutes later is on top of you. So there's an environment thing. What about a spider web at the top of a pole? Or what about a bee If you see 2 or 3 bees flying around the top of a pole in Texas or in Arizona, you know that that's probably an Africanized bee. So you're going to watch where he goes because you want to know, is that hive only 80 feet away or is it 300 yards away? Because I'm not going to do anything to describe an Africanized bee colony. So there's a question about Denver. Thank you. Will the materials be available to attendees? I'm going to answer this. I'm going to give you this if you send me your email address. And this is a like a safety meeting or a crew reminder of how this intersect works. So the discussion is up here at the top, made up of a series of work stages composed of work steps. And then you see down here in the middle, each task for the worker asks, what is it about the task that can hurt me? How do I prevent it? What is it about the tools that can hurt me? How do I prevent it? What is it about the work environment that can hurt me? And how do I prevent it? And for each hazard identified, then you have a plan. When you see what it is that can hurt me, you make a discussion about how we can prevent or protect ourselves from that issue, from that incident. So this is the three: task, tools, environment. Now, what makes this very simple is that this should become a part of your language when we're talking about the issues with the job site. When you use the intersect, it's, I don't know why three is such a great way to do stuff. And maybe it's because we can remember three better than we can remember 4, 5, 6, 7, 8 things at a time. But three seems to work. And what we also know is that when we want to keep a focus on should we call it a prime methodology of protecting ourselves, then we adopt a language to remember. And if we adopt a language such as task, tools, environment, task, tools, environment, task, tools, environment, or the intersect, and we've trained on it, then everybody knows what we're talking about with the intersect. Oh, task, tools, environment. Did you use the intersect when you did your hazard analysis today? Yes, I did. Task, tools, environment. Not too much in the environment, but we are using some hydraulic tools, so that's an issue. And we did discuss each of the tasks that we're working on. So that's how the intersect becomes easy to apply because it's a very, very simple program. What is it about the task? What is it about the tools? What is it about the work environment? And for each one of these, you're going to have somebody who's going to understand or know that the issues associated, unless you have a pole crew full of helpers, one winch suck operator and a foreman. Now you're going to have to do a little more explaining when stuff goes through, and it's going to take a little more time. But the more time you take, I tell you what, I think this is one of my favorites. I had a foreman. We were building a 500 line for a Salt River project, and they were using a new vendor manufacturer for poles and arms. And as they were hanging the arms, they started noticing visible cracks in the welds where the arms, the flange on the arm was bolted to the pole. So it turned out that they came up with a repair, and we call it a Band-Aid. And what it was 80 pounds sleeves that slipped over the arm, bolted to the pole, bolted to the arm to give a reinforcing backing. Now, there's something about whenever you hear that is something you have never done before or something that's very new, that's what you really need to pay attention to. And I told the foreman, okay, we've never done this before, so you know what my theory is on this. If we don't spend plenty of time discussing this process, then we're going to have an incident. So let's work this through very, very slowly, while you work your way through it, and go step by step, and let's use this intersect. And he said, got it. Task, tools, environment. Perfect. So I left. I went down to another part of the project. 45 minutes later, I got a call from him. He says, we're on the way to the hospital. One of his apprentices, see, all of these Band-Aids that came in, these 60, 70, 80-pound Band-Aids, were put on heavy-duty pallets, and they were strapped down with nylon binder straps. Now, this kid had a pair of Kleins in his back pocket, but he took out his knife and he was trying to cut through the binder strap. And when he finally got through, his hand uncontrolled put that 3.5-inch blade right into the calf on his leg, on his left leg. And when he pulled it out, a squirt of blood came out and he was unconscious. So I got back down to the hospital, and they're out there and they're fixing the kid and putting him all back together and everything else. And I pulled him aside and I said, "Man," I said, "I just left you and we were having a talk about working your way through each of these steps really slowly." And he said, "Well, I don't have time to follow every apprentice around and make sure he's not going to stab himself in the leg." And I said, "Wait a minute. There's your crew truck over there with your 4 crew members in it. You and I are standing here at the hospital, and you've been here for almost an hour and a half. You don't have time to follow your apprentice over and talk about cutting straps. Hey, what we're doing is we're preventing lost time." But the other thing is that when we're doing these discussions step by step, task tools environment, we are also preparing a work method that eliminates losses because nobody's trying to figure out what do I do next. Because it's essentially good task planning, it's good procedural planning, and at the same time, task tools environment, the intersect, is keeping us um, from from not focusing on the hazards or these conditions that are now they're going to get ourselves in trouble. Now, you have heard about this, and this is just a last step about what we do when we find these hazards. We either eliminate or substitute, but really this is an OSHA preferred way of solving problems, and it doesn't always work for us because we can't simply eliminate wire pulling. We can't eliminate sheaves. We can't eliminate the weight of a cross arm coming across your belt. We can't substitute and find another thing to work with it because there ain't another thing. It's the way we do it. Engineering controls, the same thing, the way we do it. So sometimes it's awareness, 2 people together, the quality of the rigging, that we use. We're not going to eliminate the hazards, but we can manage the hazards. And that's what we do when we use the Intersect. Um, so ultimately, when we're going to work and we're sending people into the fray, we don't want them to be this guy. We don't want him to be the pig in the pen. I'm going to a party, but he doesn't know what his role is when he's going to get there. Instead, what we want to do is we want to have a process that works. And we find that the Intersect works and it works very well. So remember, it's 3 parts: task, tools, environment. You add that to your language when you're discussing hazard analysis, or just add the word intersect so that everybody immediately thinks. 3 steps: task, tools, environment. What is it about the task that I'm doing that can hurt me, and how am I going to protect myself? What is it about the tools that I'm using that can hurt us, and what are we going to do about it? And what is it about this environment that we're working in that can hurt us, and what are we going to do about it? So there you go: task, tools, environment, the intersect where flesh meets threat. I hope that that has given you um, some answers, or at least started you thinking about how you can improve your processes, or how you can help your crews improve that process. Now, you see down there, you see my name. Uh, well, of course you do. You see my phone number. That's the important part: 480-708-2999. Send me a text if you have a question, or even better, there's my email address, jim@ispconline.com. And if you do that, I will send you this page right here. Now, we do have a full booklet that's part of our training. Typically, when we do hazard analysis training, it's about 12 or 14 pages, and it has a much more detailed look at how to do a walkthrough and hazard analysis and stuff like that. But if you are interested in putting the Intersect to work for you, you just heard the explanation. This is a good reminder of how that works, and you can use this as uh, a weekly safety tool, or a weekly safety talk about the process, how it works. So remember, the Intersect, task, tools, environment. That's the 3 questions that you have to ask. So I don't see any more questions that are up here. Jamie, if you have anything to add, or if you know of any questions I haven't seen, go ahead, but I'm going to give it back to you, sweetheart, and you just take over.
Thank you. I'll just ask you to send me that, and then I'll send that one page to everyone
Oh,
that
that's a good
I'm
idea.
emailing for the rest of the day, because that's been the biggest thing people want to know if the recording or the PowerPoint are available. And in case anyone missed my answers individually, we do not send the recording or the PowerPoint after the free webinars. These are shortened. Jim has done a wonderful job squeezing this into an hour, but like he said, it is part of a bigger traditional training. If you've got questions about that, you can contact Jim or me or Mac. Hit us up on our phone or the website. Any way you want to get in contact with us to schedule something else, just let us know. But as soon as this is over, I will get a report from Zoom and I can send everyone via email that one page that Jim was talking about. So that's about it. Everyone check your email boxes in the next couple of weeks for next month's free webinar. And that'll do it. Thanks everyone for attending.
All right. And thank you all. Thank you, Jamie. Bye bye.
Bye guys.